Hi everyone, my name is Chinoso and with me is Michael. Today we're going to be talking about a topic in math, which is variation, and we'll explain the types of variation and take a few examples to buttress the point or further explain the concept. So in mathematics, we'll be talking about three variations: the direct variation, inverse variation, and joint variation. So I wanted to think of direct variation. All right, thank you so much, Michael. So I'll just keep speaking and you can help me write them. Okay, so we have direct variation. And for direct variation, I'll just explain it briefly. So it's when one value goes up and then the other value also goes up to match up. Then we have inverse variation, where when one value is increasing, the other value is decreasing. Or when one value goes up, the other value is going down. And joint variation is a type of direct variation where is a special type of direct variation where one value is directly varied with the product of two values. In other words, when one value goes up, the product of two values either goes up, or when one value goes down, the product of two values go down. So I'm going to explain that in a moment. So for direct variation, this is it. So we say, for example, A varies directly as B. So that would be A varies directly as B. And then for inverse variation, so in other words, when A goes up, B also goes up. So inverse variation is saying, say for example, C varies inversely as D. So that will be 1 over D. So this is the inverse. What this means is when C is going up, D will be going down. And then for joint variation, we say it's a special type of direct variation. And in this type of variation, that's under joint, when one value, you know, varies directly as the product of two or more other values or terms. So in other words, we can say A varies directly as the product of, say, B and C. So to form the equations, we want to introduce constants of proportionality. So what we need to do is to introduce a constant. And then I would also explain a constant. A constant is a term in an equation whose value will never change no matter what. So for example, we have a cycle. In the 5th century, the Chinese mathematician Zhu Chongzi calculated the value of pi, which is the value of the circumference divided by the diameter. So if you have a diameter of a circle, you get the circumference, you divide, so you get a constant value. So the value of pi, which we know as, well, he gave it in three, well, so that's the approximate value of pi, which is a constant. It never changes. So that gives us an understanding of what a constant is. And so we always want to have a constant in our equations. So to introduce the constants of proportionality in these explanations, we would say A is equal to the constant and B. And then we can go on to get an equation in terms of the constant. So we divide through by B. We divide through both sides by B. So therefore, the constant, which is K, so B cancels B out. So our K is going to be A all over B, just as we had in in the circle where we had the constant pi, where we said pi is equal to the circumference all over the diameter of a circle. So that's the same thing here. So if you look at that carefully, you would know that the circumference is directly proportional to the diameter. Great. Okay, so for inverse variation, we apply the same rule. So we introduce the constant of proportionality. So that would be C is equal to K all over D. And to get the value of the constant, all we need to do is multiply both sides by D. So that would be CD is equal to K. In other words, K is equal to CD. So this is the constant of proportionality. Likewise, in joint variation, we want to introduce the constant of proportionality. So that would be A is equal to K B C. And therefore, to get the value of the constant, we divide through both sides by BC. And once we do that, so this BC cancels this BC out, and therefore we're left with K is equal to A all over BC. So this is the explanation to variation in mathematics. So you just have to understand this, and once you have this understanding, you can go on to solve questions. So Michael and I would respond to these questions in turns to further explain. So I'm going to take question 1, and Michael will take question 2, and probably we can take one more and then move to the next set of questions. All right. So for question 1, I'll just solve that. So it is saying C varies directly as A. So this is a direct variation question. So C varies directly as A. This is the explanation. This is the way of putting that statement. So the next thing I want to do is to introduce the constant of proportionality. So I'll say C is equal to the constant multiplied by A. And then this is the formula form. So I've written the formula form. It says, remember that this practice question is saying, write the formula that expresses the relationship described. So C is equal to KA. So this is the equation. And then we can go further to express it in terms of the constant, which is K, by dividing through by A. And therefore we have K is equal to C all over A, having cancelled this A all over A. So I hope that's clear. If you have any question, feel free to put your question in the comment section. And if you're just coming across our video for the first time, please do well to subscribe to our YouTube channel and also click on the notification button just so you're notified when we post our new videos. We make videos on algebra and other math topics. Please feel free to follow us. Thank you so much. So Michael, over to you.
Yeah, thank you very much, Mr. Chinonso. That was really clear and insightful. And when you were explaining these kinds of variation, what came to my mind that they can also want to apply, I mean, something that is more realistic in application is think of direct variation as maybe, for instance, you have to buy maybe pizza. Let's say you want to buy pizza, and pizza cost let's say $5, right? $5 for one pizza. Okay, one pack of pizza, $5, one pack. Then if you have $10, you're going to buy two pack because one pack is $5, right? So if you have $15, you're going to buy three pack. What do you observe? The more the money, the more the pack. So just like Mr. Chinoso is explaining, two quantities are going up the same. So the more you add, the more money you're putting in, the more pack of pizza you're getting. The same way it goes the other way around. If you have $100, you're going to buy around I think 20. That's 500 divided by 5. That's around 20. You're going to get 20 pack of pizza. So when the money is reducing, $50, you're going to get 10 pack of pizza like that. So you see, as the money is going down, then the number of pizza you're going to get is going down. So that is direct. They are both going up or both coming down. But for inverse, it is one is going up, the other is coming down. A real application is, let's say you have a farmland, and there are so many weeds inside the farmland. One farmer can clear this farmland within 20 days. You see, one farmer will clear the piece of land for 20 days. So, but what do you observe when you bring in more farmers? Maybe when you bring in 10 more farmers, the number of days is not going to increase, it's going to reduce because you have more workers in the farm. It's going to reduce maybe like 2 or 4, whatever. Okay, it's going to reduce. That is inverse. When one is going up, the other is coming down. You see what I mean? Then joint, like he said, is a combination of direct variation, and also it can be a combination of direct variation and inverse variation, just like we've explained. So that's just to add to your thoughts, so you can always see how this is applied in real life. Then question two, I will take question two. You say x is jointly proportional to x and z. So that is x is jointly proportional to y and z. So we want to now bring in our constant of variation. That will be introducing the constant k, and that will be kyz. And if you go further to make k the subject, which is the constant, you want to divide everybody by yz like that, and you'll be having this. Of course, this will cancel this. So you're having k is equal to x over yz. Yeah, thank you, Mr. Chino. So over to you.
Yeah, thank you so much, Mr. Michael. Awesome. All right, so I'll take question three, and then I think we can move to the next set of questions. So it is W varies inversely as X. So W varies inversely. So that will be the inverse of X. And then to introduce the constant of proportion, that's the constant. So we have W is equal to K all over X. And then to get the value of K, which is the constant, we want to multiply both sides by X. So that would be X multiplied by W is equal to K all over X multiplied by X. So this X cancels this X, and we're left with K is equal to XW. So this is the simple way of solving it. So you would notice, our dear students, that as you understand it, it becomes very easy. So in mathematics, one of the things you want to do is you want to practice a lot until you increase your fluency in dealing with questions. Thank you so much. So I think we can move to the next set of questions. And please feel free to drop any question you have in the comments section. We'll be more than happy to respond to as many questions that you have to ensure you meet your goals. So these set of questions, what we need to do is find the constant of variation and write the formula to express the relationship using that constant. So in this set of questions, we are going a step further. We have values of the terms or the so we have exact values, and we want to get the value of the constant. So we'll take the questions in turns again, Mr. Michael and I. And of course, we trust that you should be able to understand. So I'll go first this time again. So we have question 10. And 10 is saying so question 10, A varies directly as B. So again, so I want to form the equation first. So that would be introducing the constant of variation. So that would be A is equal to KB. And then I can form the exact equation in terms of K by dividing through by B. So that B is equal to, sorry, so that K, thank you. So I'm dividing through, remember I'm dividing through by B. So this B cancels this B. So I'm left with K is equal to A all over B. And then from the question, it is given that A is equal to 15 and B is equal to 5. So I want to see that in the in this equation that I've 5. K is equal to 15 all over 5. Therefore, K is equal to very easy to question.
All right. In continuation to this, you just want to plug in the values of A and the values of B. So you have K is equal to A is 15 and B is 5. So you have 15 over 5, and that will be equal to 3. So the value of K is 3. So that's pretty much how to solve question 10. All right. So let's go to question 11. Question 11 says P, we want to do 11 right about now. Question 11, it says P is jointly P is jointly proportional to Q and R. So that's going to be like P is jointly proportional. This symbol is the symbol for proportionality. Okay, that's the symbol for proportionality or variation. Okay, so P is jointly proportional to Q and R. Okay, now the next thing you want to do is to introduce your constant of variation or constant of proportion, and that is K. So that will become P is equal to K Q R. You get it? And now you want to make K the subject, so you divide everybody by QR like that. And finally, these guys cancel out. So K is just equal to P upon Q, upon QR. Now, the next thing you want to do is to plug in these values of P and the values of Q and the values of R. All this, the mission here is to get the constant of variation, and that is K. So all of the problem here just wants to find K. So that is why we are making K the subject. So when you put in these values for P is 12, Q is 8, that will be 8 times, R is 3. So 8 times 3 is going to be 24. So that is, we have 12 over 24, right? And finally, this is going to be 1 over 2 to its lowest term, that is half. So that is the answer for question 11. So if you have any doubt while you're watching this video, kindly let us know in the comment section. And if you have maybe if you want to join our one-on-one classes, do well to reach us on the link on the description of this video. Okay, you can also join our one-on-one classes. We do the SAT, we also do the GRE, we do other kind of maths, high school maths, middle school maths, elementary school maths. We do all of this stuff on our website. So kindly go join and check us out on the website. So let's do question 12. That will be the last in this particular section. Question 12. Let me clear up the whole screen. So question 12, it says C, let me put it here. C varies inversely as D. So how you want to write it is C varies inversely. You just want to write 1 over D. So this means C varies inversely as 1 over D. And now for you to solve this problem, you introduce the constant of variation, which is going to be K over D. You get what I mean? Now you want to cross multiply so that you have CD is equal to K, or you want to say K is equal to CD. I mean, that is much more easier. Then what is now C and D? The value of C is 7 and the value of D is 4. So when you plug in the value of C at 7 and D is 4, you know, CD, the relationship between C and D is multiplication. That's why we are doing 7 times 4. Okay, C times D is the same as CD, okay? And that's why we are doing multiplication. So K is finally going to be 28 because 7 times 4 is 28. So that will be all for this particular question. I mean, if you don't mind, you can go ahead and do other more problems. And if you have difficulties here, no problem, just reach out to us. We're going to help you as soon as possible. So thank you for watching to this very point in time. We'll see you in the next video and have a wonderful day. God bless you. Bye-bye.